Hello everyone, I hope all of you are doing fine. We all know how amazing Google Lens is. Imagine a situation that you visit a new country, a new city, and you happen to discover a new landmark, but you don't quite know the name of the landmark. It is here that you open your cell phone and you point the camera towards the landmark, and that's about it. Google tells you what landmark it is. Now, what if I tell you that you can create the exact same solution, a web interface, using very little lines of Python code? So without wasting any further time, let's kickstart the video. Now you might wonder, what exactly do you need in order to create the solution? Well, the answer is very simple. All you need is a working internet connection. The compute will be handled by Google Colab. So I'm creating this demo entirely on Google Colab, and essentially I'll kind of download a pre-trained model and show you the magic of TensorFlow Hub. I am currently on TensorFlow Hub, and let me click on landmarks. So Google currently has some pre-trained models wherein you are able to identify landmarks directly. You don't need to train a model for it. All of this is already taken care by Google. So the different continents that are available at this point of time, you have Africa, Asia, Europe, North America, and so on and so forth. What I want to create today is a specific solution for Asia. So I'll select Asia. It is here that you can find Asia. So I'll click on this particular link. Don't worry about the web page. I'll add the link to the web page in the description section of the video. So feel free to check that out as well. So now I'll keep going down. Here you have a pre-trained model. Let me try out the entire process on this web interface that is available. So let me quickly upload an image. So I'll upload this particular image, that is image1.jpg. The output of the model was almost instantaneous. And the landmark that you see here is Gateway of India, which is in Mumbai. Now, if you want to replicate the entire process and create your own web interface, this is what the video is all about. What all do you require? You require this particular URL, that is the pre-trained model link. So I'll copy this as well. Whenever you are about to use a model from TensorFlow Hub, make sure to read the input and output values of the model. It clearly states that the model requires a 3-channel RGB color image of a particular size, and the input values have to be scaled between 0 to 1. So keep this in mind. I'll kind of show you how you can do this when you create your own web interface. The model outputs to prediction logits. So this is the key that we'll have to use in order to extract the output. And there is something called as label map. So essentially a label map would contain mapping of the ID with the exact landmark that is there in the model. So we'll be utilizing this as well. This essentially is a CSV file. So I'll be utilizing this CSV file as well. So with the whole background work done, I'll quickly move on to the coding section. So there is some starter code that is already available. I'll kind of utilize this as well as we move forward. So without wasting any further time, let's kickstart the activity of creating our own Google Lens-like application for detecting landmarks using Python. In order to create a web application quickly, I'll be making use of a Python library called as Gradio. So now let's jump to the coding section. So this is a brand new interface on Google Colab. I've not played around with any settings. So let me quickly go and click on connect. So we have an instance up and running. The first thing that I'll do is I'll install Gradio. So the way I would do that is pip install Gradio. So let me quickly run the cell. The installation is done. Now I'll quickly import some necessary modules. So I'll firstly require NumPy. I'll require pandas. Most of you would be aware that you require NumPy and pandas for such activities. I'll also require matplotlib just to show you the image. So import. I'll also import Gradio. I want to show you the images as well. So I'll require pill. Next up, I'll require TensorFlow. I'll also require TensorFlow Hub. This is all that I require. So I'll quickly run the cell. If you're trying to replicate this entire process in your local system, then you will require all the libraries that I've mentioned right now. If you're using Google Colab, then the only thing that you will require is Gradio. So you'll have to install it first and then import the necessary modules. I've already copied the model link in the clipboard. So I'll paste it and I'll assign it to a variable called as tf_model_URL. So let me create it first. So this is the link to the model. The next thing that I also require is the label map, that is mapping of the IDs to the exact monument or landmark. So I'll create a variable label map URL and I'll paste the link which I've already copied again in the clipboard. So I'll paste it here. So this essentially is a CSV file. If you remember, the input shape that was required by the model was 321 cross 321. So let me define a tuple with the name image_shape and I'll create a tuple 321, 321. So let me go forward and run the cell. Now I want to download the entire model into a variable called as classifier. So the way I would do that is I'll define a variable called as classifier tf.keras.sequential. I'll define a list which contains the layers that I want to import from the model URL. So I'll pass in the model URL here. The input shape is what I'll define, equal to image shape. But the images would have 3 channels. So I'll kind of introduce 3 channels here. And if you remember the output key, so if you remember the output key was essentially predictions logits. So that is what I'll write here. So everything that was mentioned in TF Hub documentation for this particular model is what I've replicated here. So let me go forward and run this cell. Alright, so I have the model inside my variable classifier. Let me also read the label map. So I'll create a data frame df. I'll read the CSV directly from the URL. Label map URL. Okay. Just to show you what label map actually looks like, I'll say df.head. So 0, 1, 2 is what you have. So you have your ID and you have the name of the monument or the landmark. Now, if I want to use this label map, what I'll do is I'll create a dictionary called as label map. And I'll have key value pairs in such a format that my keys would be the ID and the name of the monument would be the value. So the way I would do that is dict of zip df of id and df.name. So now if I show you the label map, I'll have a key value pair, something like this. All right. Before we go forward and create our own web interface that can essentially replicate Google Lens on the web, the first thing that I'll do is I'll take some predictions and check if the entire logic is falling in place or not. So the first thing that I'll do in this activity is I'll upload an image. So I'll click on files. There is no image currently. I'll browse my local system. So it says upload. So I'll go here. I'll click on image1.jpeg. I'll click on OK. So the image has been uploaded. I'll close this. Now I'll load this image into a NumPy array and then take predictions from it. So the first thing that I'll do is I'll create a variable called as image lock, and I'll pass in the image name, which is image1.jpg. Let me check if it's capital or small. It's capital. So we are on the right track. So let me go forward and run the cell. Now I'll use pill to essentially show you what the image is. So image.open. I pass in the image location, which I've just defined in the previous cell, and I'll also resize it. I'll pass in the initial tuple, and that's about it. I'll now show you the image. So this is the image. If you've been listening throughout, then one other requirement that the model has is that the intensity values have to be scaled between 0 to 1. So the way I would do that is, again, I'll create the same variable again, img. I'll create an array now, and I'll divide all the elements of the array with 255.0. So now if I show you the image.shape, I have a NumPy array which essentially has 321 rows, 321 columns, and 3 channels. Just for you to make one prediction at a time, I have to do one more thing, which is I have to add one more axis at the start. So I'll do that by image np.new axis ... Now the shape of the image would be 1, 321, 321, 3. So we've reached the final stage. Now I can make a prediction from this particular model. Given that our input shape is all in place, our model is in place. So now I'll define a variable called as result. I'll use the classifier variable. I'll call the predict function, and I'll pass in the image. Now if you look at the results, it contains probability values. The total length of the result would essentially be the total number of classes for which the model has been trained. So just to give you context, if I do result.shape, essentially you have 98,960 classes for which the model has been trained. So you might have a question now, how do you get the exact name of the landmark? Well, if you remember, we had created a dictionary called as label_map. So let me call label map, and now pass in the probability scores, which is result. But rather than using all the scores, I want the index or ID of the maximum probability score. So the way I would do that is, again, using the function np.rmax. I pass it here, and the landmark name is Gateway of India, which is in Mumbai. So it's doing a terrific job in terms of running locally. So now the next piece of the puzzle is, how do you convert this amazing small application that you've created into a full-blown web application? Well, it is here that Gradio will help us in creating an amazing web application with minimum lines of code. So I'll show you the power of Gradio. I don't have to do a lot after this. So let me first create a function called as def classify image. I'll pass in the image. I'll say image equal to np.array image. So all the pre-processing steps that you have done for the model is essentially what you'll have to do if you take in an input again from the interface. So the input that you would receive essentially would be a numpy array. So all the manipulations that you do after you get a numpy array is what you'll have to replicate. Now I'll also have to add a new axis. So image dot np dot new axis prediction equal to classifier is what our model name is. I call the predict function. I pass in the image and I return the label map np.argmax prediction. So our function is set up. This is the function that we'll be calling once we define the interface. Now how do you define the interface? Well, again, it's a 3-line code. Our main input function is ready. Here we are taking in the image. We are doing some pre-processing. We are calling the predict function from the model, and then we are returning the name of the landmark that has been detected. Now if you have to create a web interface really quickly using Gradio, all you require is an input, the output label, and basically an interface. So let me go forward and create that. So our input would be an image again. So image equal to gr.inputs dot image. I am basically inputting an image. I also define the shape. So again, this would be 321, 321. You can pass in the tuple directly. Then I'll also define the label. Label is essentially your output. And I say number of classes, top classes equal to 1. In this example, I'm giving out just one class output. Ideally, I can skip passing this argument as well. Now I'll create the interface by calling in gr.interface. The first thing that I'll require is the function. So that is classify image, the input, which is again image in our case, label, and I'll also set capture session equal to true. That's about it. So I'll quickly run the cell. We've created the interface. The only thing that we've missed out on at this point of time is launching the interface. So let me call the launch function as well. So let me click run. So now the interface is launching. You can basically use this URL as your web interface. But the good part about Gradio is the interface launches within the Google Colab session itself. So that is something that is unique about Gradio. And here you have it. You have the interface ready. Now let's play around with the interface. So let me click to upload the image. So I have image1.jpg. I'll click on submit. And here you have the predictions. That is Gateway of India. Let me try out this interface with a second image as well. So let me click on clear. Let me upload the second image. This is a very famous monument in New Delhi. And let me click submit. So it says India Gate. So if you notice carefully, we've just built a Google Lens version of detecting landmarks with very few lines of code. Isn't this amazing? You can also create an Android app. You have a corresponding TF Lite model as well. I'll share across all the links that are relevant for this exercise in the description section of the video. Just before we end, I want to also check the web interface. So let me click on the web interface. So this is the web interface that is publicly hosted. I'll upload the image again. I'll press submit, and there you have it. So the web interface is now running publicly as well. The URL would be active for around 24 hours, after which it's kind of removed. But yeah, I mean, if you want to create web applications as quickly as this, then Gradio is the way going forward. So yeah, this is all that I had. I wanted to show you the power of open source and how you can create some amazing web applications using TensorFlow Hub and the pre-trained models that exist there, along with Gradio, which is again an open source library. So if you truly enjoyed this video, feel free to share it across with your friends, and thank you so much for watching this video.